Alright, with a simulation of position control in hand, it's now time for us to implement this for our robot. I'll start by just creating a new sketch. And I'll put it inside the exercises folder. And we'll call this one maybe position control. Inside this new folder, I created the INO file, so the entry point for our Arduino sketch. But I know we'll also want a header file to put our implementation of position control in. I'm also going to grab the make file and the configuration file. And we're ready to start coding up our project. I know that I'll want to continue using the WebSocket communicator. So let's start by bringing in that object. If we were to jump into the constructor for the WebSocket communicator, we'll see that it requires us to pass in the SSID, the port, and the update interval for heartbeats. So that means I'll need the SSID, a port, and a heartbeat interval. So those are three things that I need to define. Let's put all of those behind a comment here that calls this the network configuration. The network you'll use is the Pomona Wi-Fi network. And you can really choose any port that you want, but 8181 has been working for me. And we'll set the heartbeat interval at 1 second. Now for our WebSocket communicator, we need to make sure that we call its setup function. And as a reminder, what we do here is we call the constructor of the WebSocket object. And here we call the setup method. What belongs in both of those methods depends on the type of data that you're initializing. So for example, simple objects like the interval timer or SSID or port, those can all be initialized by the constructor itself. In setup, we'll want to do things that take longer and that should happen after the Arduino initialization. So that includes things like starting Wi-Fi and waiting for Wi-Fi. And likewise, starting and waiting for the WebSocket communication to start. In general, you'll initialize really simple things in your constructor, and more complex things that should wait until after Arduino has done its initialization. You'll put those in the setup method. And now we have our WebSocket communication up and running again. This isn't actually doing anything but accepting messages. But this will be needed if we want to then check the status of the WebSocket communicator to see if it's been enabled. So that way we can ensure our motors are only running as long as we haven't lost connection to our robots. The next thing I'll add is the display. It may be that we'll have this program running for a long time and we don't want to have to connect to a USB cable every time we want to connect to the WebSocket interface. So we'll display the IP address and port. So for the display, there's a display object. And similar to the WebSocket communicator, we'll call display.setup. And in this case, we could also call display.loopstep. But my version of display doesn't do anything in loopstep. There's nothing that I need to continually run each time. So I can choose to delete this, or I can just leave it there and know that the compiler will probably optimize it away since that function does not do anything. Speaking of which, I need to tell the compiler where it can find the display code. And if we were to jump into the display code, you would see that the constructor creates the display object, because we need to make sure that the display object has the correct constructor called, and we only want to call it once. We don't want to have to do it inside the body here. And then the more complex initialization, where we're setting the font or calling .begin on the display object. That happens inside our setup method. And of course, like I mentioned, loopstep doesn't actually do anything in this case. I really just have that there as a reminder that all of our classes should have a setup and a loopstep method at minimum. Arguably, they should all have something like a reset method, but I didn't want to add extra complexity to all of our classes if not needed. Something else I should mention. The WebSocket communicator, that constructor requires arguments. In fact, it requires 3 arguments. The display constructor, if I were to jump back into it again, does not require any arguments. You might be tempted to call the constructor like this. C++ will see this syntax and assume you're doing what's called a function prototype here. So the correct way to call the default no argument constructor is just to leave off the parentheses altogether. In my version of the display class, this is where I will display information. The display is persistent, so I'm just going to call it once inside setup, and the only thing I would put in loop is if I were updating the display with new information frequently. If it's static information like the IP address, I would just do that in the setup method so it only gets called once and we're not wasting time. So we'll call drawString. I'll give it a line number, an indentation, and let's say that the first thing we're going to say is just what is this sketch about. This will be our position control sketch. On the second line, same indentation level, let's put the IP address. On the third line, let's put the port. And the error message here is saying that drawString requires a string as its third argument, but we're passing in an integer. Luckily, there's a string class that gets included inside display at the top here. This WString class lets you convert from an integer into a string. If we wanted to be more explicit about that import or that include, I could also include it here. I'll often do that just as a reminder that's where something comes from, instead of having to worry about, okay, where is string defined? Well, that's defined inside this display header. This also makes it easy for me to jump to that file if I wanted to. There's now enough code here that it's worth me compiling and seeing if this will run. So I brought over our makefile, and that will be the easiest way for me to check to see if this thing compiles. And it looks like the compile command checks for a USB connection. That's not strictly necessary. I could change the makefile to eliminate that problem. But if I look, I currently don't have my board connected, and so that's what this complaint is about. I'll plug in my board and rerun this command. I've plugged in the board, and if I check now, that USB item is there, which means I should be able to compile this time without trouble. After a good 31 seconds of waiting, this program compiled, and now I can call makeupload. I could have started with makeupload and it would both compile and upload. I just wanted to show the multiple steps here. because often it's worth compiling without trying to upload just to see if all of your code is syntactically correct. The program uploaded, and I'll refrain from turning on the camera to show the robot because all it's currently doing is displaying that information exactly as I requested here. Alright, I'll cut this first video here, and this will be a good one to reference when you want to start a new sketch. I recommend starting with the command line, the Arduino new sketch commands, but then for the most part you can copy over a lot of this stuff from existing sketches instead of typing it all out by hand. I decided to create this video because it's been a while since we've talked about a few C++ syntax things, like the fact that this no argument constructor shouldn't have parentheses, and that every class we create should include both a setup and a loop step method. Alright, so in the next part of the video, in the next video for this chapter rather, we'll start working on our kinematics and motor control.